Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you can find information for online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. You can notice that you have BTDT in every single URL there and every single address, and that's because BTDT stands for Been There, Done That, and that's a brand of my study manuals that I use because when you take an actuarial exam, every time you look at the problem, you should be able to say, been there, done that, because you've done problems like this before. If you're not able to say that, it means you didn't really prepare for this exam and you're hoping to get lucky, and you shouldn't be like that. You should over-prepare for actuarial exams. You should study for a 10, or even better. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help ISU Actuary. Here's a problem for today for exam FM on financial mathematics. A 16-year loan of L is repaid with a payment at the end of each year. During the first 8 years, the payment is 100. During the final 8 years, the payment is 300. And of course, you can model this as either a payment of 100 for 16 years and an extra payment of 200 in the last 8 years, or you can model this as a payment of 300 for 16 years and then subtract from that a payment of 200 in the first 8 years. Interest is charged on the loan at an annual effective rate of I such that 1 over 1 plus I to the 8 is more than 0.3. After the first payment of 100 is made, the outstanding principal is L plus 25. Calculate the outstanding balance on the loan immediately after the 8th annual payment of 100 has been made. So you can see from this, by the way, that these payments of 100 are kind of small in relation to what needs to be paid for two reasons. First one is that you need to make much larger payments in the last 8 years, but also the statement after the first payment of 100 is made, the outstanding principal is L plus 25. This is actually telling you that the payment of 100 was not enough to decrease the balance of the loan. The balance of the loan increased by 25, which means, by the way, that no principal was paid off, and in fact, the interest must have been more than 100, and in fact, you can see that the interest amount in the first payment should have been 125, 100 the payment that was made, and the 25 that was unpaid and was added to the principal outstanding. So again, we calculate the outstanding balance on the loan immediately after the 8th annual payment of 100 has been made. And here's the solution. The principal repaid in the first payment is 100 minus IL. After that payment, the outstanding principal is L minus 100 plus IL, but that's really L minus the quantity on 100 minus IL. And this is known to be L plus 25, and so IL is 125. So the principal repaid in the first payment is negative 25, meaning that principal balance increased. We also know that L is equal to 300 A angle 16 minus 200 A angle 8. In other words, 16 payments of 300, but in the first 8 years, 200 is missing. That's equal to 300 times 1 minus 1 plus I to the negative 16th, minus 200 times 1 minus 1 plus a to the negative 8 over I. Let's just combining the two formulas for the present value of an annuity immediate. And this implies that I times L, you get that from the denominator of the right-hand side, and multiplying both sides by it, you get IL on the left-hand side, and the difference of those two expressions on the right-hand side, the two expressions that you see in the numerator now. So IL, which is 125, we just established that, is equal to 300 times 1 minus 1 plus I to the negative 16th minus 200 times 1 minus 1 plus I to the negative 8th. And that's equal to simply 100 plus 200 over 1 plus I to the 8th minus 300 over 1 plus I to the 16th. So that 300 over 1 plus I to the 16th minus 200 over 1 plus I to the 8th plus 25 is equal to 0. Let's write z to be 1 over 1 plus I to the 8th. Then the equation that we have becomes 300z squared minus 200z plus 25 equals 0. This, of course, is a quadratic equation, and its solution is z equals 200 plus minus the square root of 200 squared minus 4 times 300 times 25 over 600. That's 200 plus minus 100 over 600, and that's 1/6 or 1/2. But z is equal to 1 over 1 plus I to the 8, and we are given that 1 over 1 plus I to the 8 is more than 0.3, which means that z has to be 1/2. So 1 over 1 plus I to the 8 has to be 1/2, because 1/6 is less than 0.3. We are looking for the outstanding balance on the loan immediately after the 8th annual payment of 100 has been made, and this just equals the present value of the remaining payments of 300, so that's 300 A angle 8, which is 300 times 1 minus 1 plus I to the negative 8 over I. 1 plus I to the negative 8 is 1/2, so that's 300 times 1 minus 1/2 over I, and because 1 over 1 plus I to the 8 is 1/2, we can simply solve this for I, and that would give us that 1 plus I to the 8 is equal to 2, so 2 to the 1/8 is equal to 1 plus I, so I is equal to 2 to the 1/8 minus 1, and that's what we have here. And now we just calculate this, and this is approximately 1657.32, which is answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.